So this all started with this comment here. Does Brenda know? In fact, let me just tell you, this is a comment section on Flatzoy's last live stream. Brenda in chat making all sorts of nonsensical claims. But so I put this comment. Does Brenda know the line of sight is to the celestial body? The ground is the baseline. These pretender clowns. Nah, obviously this has triggered quite a few, but yeah, I made a claim, so first of all, let me back it up. Angle of elevation. The angle of elevation is a widely used concept related to height and distance, especially in trigonometry. It is defined as an angle between the horizontal plane and oblique line from the observer's eye to some object above his eye. Eventually, this angle is formed above the surface. As the name itself suggests, the angle of elevation is so formed that it is above the observer's eye. For example, an observer is looking at a bird sitting at the rooftop, then there is an angle formed, which is inclined towards the bird from the observer's eye. The elevation angle is used in finding distances, heights of buildings or towers, etc., with the help of trigonometric ratios such as sine, cosine, and tangent. Angle of elevation definition. The angle of elevation is an angle that is formed between the horizontal line and the line of sight. If the line of sight is upward from the horizontal line, then the angle formed is an angle of elevation. In the above figure, you can see an observer is looking at the object standing on the ground, forming an angle with the line of sight and horizontal line. Here, if we join an imaginary line between the object and the end of the horizontal line, a right-angled triangle is formed. Thus we can use here trigonometry concept to find the distance of the observer from the tower or building. Height of the tower or building, or the height at which the object is kept, will be considered as perpendicular, and the horizontal line will be considered as adjacent side of the triangle formed. That debunks McToon straight away. And then this guy pops up, Professor Phil Bell, globe defender extraordinaire, also Wise Phil, who starts talking about hills and all sorts of nonsense when we're supposed to be talking about celestial navigation at sea, but that's Phil for you, like. This is one that gets me. This is so funny. The hill is not a flat surface, and yet I have no trouble getting an elevation angle. And I can get an elevation angle from top of my flat. I can get an elevation angle from deck of a boat. Your point is. But this is the one that worries me. The ground beneath my feet is irrelevant.
You know what they say. Those who can't do, teach.
If it's irrelevant, Phil, what's the point in celestial navigation? Because we're navigating the surface of the Earth. Problem with Phil is he's spent a life of indoctrination and he's got pride in his qualifications, and it just blinds him. It's stopping his rational thought. It's just silly. I mean, go away, Phil. You've naught to offer. Naught at all. And then you get idiots like this guy, Catwalk. Michael Cairn sounds like you really cannot answer Phil's question. Typical Flav match. Blah, blah, blah. Usual, just words. I've answered Phil. They're just words. Then, when you click on them, and you go and look at the channel, no content, no subscribers. Joined February 2022. Sock account. Best place for you, mate? Dart River. Next. Frups. Michael Cairn, you always operate in the same way. Initially you make a silly claim. Claim backed up, mate. And when challenged, you'll never answer questions and always deflect. Projection. After having spewed some gibberish, you run off to the next thread and repeat the same nonsense that you could not substantiate previously. What a complete idiot. Click on his channel. Frups, 9 subscribers. Oh, wow, he might have got some other soccer accounts that he's subbed himself. That's how sad these people are. About. Joined 14th August 2011. Probably an old soccer account. Best place for you, mate? Dant River. Next, Daryl Kimmel. Do you know the baseline of measurement is a sensible horizon and not the visible horizon? That's why there is no dip correction needed with bubble sextants, even at 20,000 feet in the air. It's measured from the zenith, which is always perpendicular to the sensible horizon at any elevation. Yeah, you don't do dip correction when you're using a bubble sextant. But as for sensible horizon and visible horizon, there's only one horizon, mate. Anyway, click on his channel. 1 subscriber, no content. Joined in 2019. Probably a soccer account, but either way, best place for him. Dant River. Next, the Cuckoo Tree. Calm down, take your meds, try not to get so wound up. I think me and calm down, mate, and you're a soccer account. I think you need to take your meds. No content. Joined 2nd of April 2022. Soccer account. Talk about people taking meds. What's this behaviour all about, pal? Best place for you, Dant River. Right, back to Professor Phil Blurf. My question to him. Since you're travelling the surface and navigating it, I'd say you have no clue what you're talking about. Personally, I think you're a troll and not a professor. So explain why a sailor at sea using a sextant doesn't need to do eye-to-eye correction if it's in, let's say, is in a dinghy. And all you get off Professor Phil Bell is, which fool told you that? They don't. No, like evidence to back him up, just which fool told you that. Well, I'm going to tell you which fool, Phil. The fool who wrote this book. So just reading what's underlined in red. First, let's look at height of eye. Obviously, we want to reduce the height of eye so that we can compensate for the difference in the height of the observer above sea level. The higher we are above the horizon, the greater the correction that we have to include. We want to mathematically reduce our height of eye to sea level. This is referred to as dip, and it is always subtracted, as it must be, because unless swimming or on a life raft or a dinghy, Phil, you will always be above the horizon. So, who's a fool, Phil? I think it's you, mate. And last but not least, Pirate Guy. No content, no subscribers. Joined 12th of Feb 2021. Soccer account. Best place for you, mate. Dant River. Pirate Guy. Michael Kahn. Why a sailor at sea using a sextant doesn't need to do eye-to-eye correction, nobody does eye-to-eye correction, is a flat earther invention. You, my friend, whichever globe coward hiding behind this soccer account, are one of the silliest people on this earth. Right, this is from a website called astrolabesailing.com, and this is going to debunk your numbskulls like Pirate Guy, Phil B, pretty much every globe troll there is out there who has no idea what dip correction is. Let's take a look. Dip. D or dip, eye-to-eye correction. If you're taking your sextant readings from the bridge of a big ship, then you are going to get a different sextant reading to if you were on a small yacht. Therefore, we need to make a correction to what your sextant says to get your reading converted to a sea level reading. This is called dip, or an adjustment for your height of eye. And then it says take a look at the table below. On the right hand side is a column called dip. So let's go and have a look. And this is in your almanac, boys. And look at that. Dip. Height of eye correction.
In this video, we'll explain how to obtain an apparent altitude. When you calibrated your sextant, if you were unable to remove the index error, then you noted the index correction needed. Note this index correction on your sight reduction form in arc minutes. If you were able to calibrate the sextant, then this value should be 0. Note 0 or NA for not applicable. In our example, we'll assume it is not applicable. Next, you need to estimate your dip correction. This is simply the height from the sea level of the sextant during observations, or, if you're on land, the height from the ground to the sextant, providing the ground is level with the horizon. A good navigator has thought ahead on what this height is in calm waters, and takes sextant measurements from the same part of the ship if possible. In our example, let us assume that our sextant is 2.3 meters above sea level or above the level plane of the horizon. Often, you must contend with waves. These waves not only rise above sea level, they also have troughs between them that sink below sea level, and we need to account for this in our height estimate. Sextant measurements are typically taken at the crest or top of the waves, as this gives the best view of the horizon. Take the average height of the waves and cut that value in half. Add this to what your height would be in calm waters. In our example, let us assume the waves are 6 meters high, so we add 3 meters. Remember, our height in calm waters was 2.3 meters, so adding 3 meters, we now have a total of 5.3 meters for our estimated height. Once you have your height in feet or meters, go to the Nautical Almanac, to the first page on the right, and look up your dip correction. Note the value in arc minutes, denoted with a single apostrophe, on your sight reduction form. In our example, we had 5.3 meters for our height, and we see in the dip column that this translates to minus 4.1 arc minutes. We note this as our dip correction. So in most instances, index correction and dip correction are calculated before you obtain your sextant measurement, which is why they're listed first on the sight reduction form. Finally, measure your apparent altitude with your sextant and note it on your sight reduction form in units of degrees, plus the fraction of degree in arc minutes. In our example, let's assume we measured the sun at 26 degrees and 18 arc minutes above the horizon, so we note this as our sextant altitude. Add the index correction and dip correction to your sextant altitude, remembering that if either is negative, you instead subtract it, and this gives you your apparent altitude. In our example, we subtract our dip correction from our sextant altitude, which gives us a value of 26 degrees and 13.9 arc minutes. This gives us our apparent altitude, commonly known by the initials HA. To test your understanding of what we've covered in this video, click this link. It'll take you to a few questions designed to help you remember these concepts. Once you are comfortable with this material, you can move on to our next video, Observed Altitude, by clicking on this link.
So this is to all flat earthers out there who have a channel and upload content, or anybody in truth for that matter. It's time to start deleting these trolls and blocking these sock accounts. They've got nothing to offer. They're just stopping people finding truth. They're gatekeeping truth, and it's got to stop. Flat Earth's never going to get anywhere while we're forever arguing with these idiots.